Hello everyone. In this video I'll be doing the second part of section 2.1. And so we had talked about relations, we had talked about functions. So a function is a kind of relation where each input gives us only one output. So we always, in theory, know what we're going to get. If we look at graphs of relations, we can quickly distinguish the functions from non-functions. So let's look at this example. We're looking at all of the combinations of x and y where x equals y squared. And what I'm going to do is I'm going to graph this on Desmos. It'll just do it automatically. You don't really have to worry about why it knows how to do this. It looks like so. So this shape is called a parabola, and it's sideways in its orientation. So I'm just going to draw a very basic picture. We don't need the details, we just need the pattern. Here's our x-axis. Here's our y-axis. And it looks like so. In contrast, if we look at y equals x squared plus x, y equals x squared plus x. That's also a parabola, where this shape is exactly the same size and shape as the other one, but it's moved and has a different orientation. So that blue one looks something like so. And again, we don't really need to worry about the details. This is a little more of a blown up version. Here's my x-axis, here's my y-axis. What we might notice is over here, if we have, for example, the point 4, 2 and the point 4, -2, they're both on the graph, because whether y is 2 or -2, when we square it, we get 4. So this is not a function. The input x equals 4, corresponds to multiple output. And what that looks like on the graph is we have one point that is directly above another point. And another way of thinking about that is we have a vertical line that crosses twice. If a vertical line crosses twice, it means we have 2 points where the x coordinates are the same. These 2 points both have x equals 4, but they have different y. So the vertical line is going to go through both of them at 2 different points. This is a way of visualizing that it's not a function. I draw a vertical line and it crosses twice. Now that's not true about every vertical line. If I draw this vertical line over here, it doesn't cross at all. If I draw the y-axis, it crosses only at one point. But what's going on here is there's some vertical line that crosses twice. That means at least some of the time we're not getting unique output. While over here, you might notice, whatever I choose for x, there's only one y. Whatever vertical line I throw at this, it intersects in only one point. Right? Here's the only place that intersects. I don't know why I put the arrow in it. Here's a vertical line. Here's the only place where it intersects. Here's a vertical line. Here's the only place where it intersects. No vertical line crosses more than once. Every x has its own y. So this is summarized in what's called the vertical line test. The vertical line test is very handy, but make sure you absolutely know it. If you just remember, oh, it's something about lines and verticals and functions, that's not going to help you. You need to be very specific. So here's what it says. If some vertical line crosses the graph of a relation more than once, just some, right? Just 1 or 2 is enough. If I see some line, some vertical line crossing more than once, then it's not a function. But if no vertical line crosses more than once, then it is a function. So if we imagine the graphs of some relations, I'm just going to draw 3 examples really fast. In most cases, you can instantly tell if you're looking at the graph of a function or not. I will draw this example, I will draw this example, and I will draw this example. For the one on the left, there we go. A vertical line crosses twice. This is not a function. Here, for this second one, every vertical line crosses only once. This is a function. Same for the third one. Now, there is a difference between the last two. If we look at horizontal lines, some horizontal lines cross this only once. Some horizontal lines cross more than once. But that's not what we're assessing here. So I'll just make this as a little note. If some horizontal line crosses more than once, the function, sorry, I'll say the relation might still be a function. We're only talking about what's called a vertical line test. We might have an example where the input of 3 gives us the output of 5, and the input of 8 also gives us the output of 5. In either case, if I ask you, what do we get when we plug in 3, there is only one answer. If I ask you, what do we get when we plug into 8, there is only one answer. The word unique is sometimes confusing, but the real issue is if I tell you the input, is there exactly one answer for output? It might not be the same answer for every input. But in a case like this is still a function, even though we repeat output. Functions never repeat input, they might repeat output. Okay, when we know we have a function, the input is paired with a unique output, right? One specific output. And usually we can give a function rule that describes what's going on. So let's look at a few simple examples. I'll give a quick table of x and y. 1, 2, 3, 4, 5, 6. Same thing over here. 1, 2, 3, 4, 5, 6. And maybe here I'd have 4, 8, 12, 16, 20, 24. Maybe, let's make that 16 much more legible. I'm going way too fast. And over here, let's suppose we have 3, 5, 7, 9, 11, 13. In each case, you might be able to notice the pattern as we move along this column. That's sometimes nice to notice, but for a function rule, we want to explain how are x and y directly related. What can I do to this x as input to get this y as output? What can I do to this x as input to get this y as output? What can I do to this x as input to get this y as output? And for the first example, I hope you will notice that the y coordinate is always 4 times x. We would call this the function rule. Because once we have a rule, we don't need the table. If I wanted to know what do I get when x is 13, I don't have to keep running through the table. I can just apply the rule and say, oh, it's going to be 4 times 13, which is 52. Now, over here on the right, it may not be as obvious. And with some practice, you'll get better at this. In pre-calc, you'll learn very specific ways of doing this. Sometimes we don't notice the function rule, but then once someone proposes one, we observe that it's correct. So here, maybe you came up with it. Again, if you say we add 2 every time, that's correct, but that's not how function rules work. In the function rule, we explain how do we get from x to y, and you might notice if we take twice x and then add an extra 1, that'll do it. Double 1 is 2 plus 1 is 3. Double 3 is 6 plus 1 is 7. Double 4 is 8 plus 1 is 9. So again, if we have this function rule, it makes it a lot easier to do things without the table. If I tell you that x is equal to 87, then we don't have to churn through the table. We know y would be 2 times 87 plus 1. Doing this in my head, 174 plus 1, so hopefully that's 175. So function rules, again, let's be really clear, describe how to get from an input to the corresponding output. They don't tell us how to get from one y to another y. Now, when we talk about functions, we often name them using a letter, and we use function notation to explain the rule. Let's look at an example. So in this example, the function is named f. A single letter is the name of the function. And then the function rule is, we pronounce this as f of x. This is not multiplication. So f of x is basically telling us what output does f give for the input called x. This is really just another way of describing the function rule, but it does it in a way where we can talk about multiple functions at the same time. If we call everything y, it gets confusing. But if I can say, oh, I have one function, right? Function number 1 has the rule f of x is x squared plus 2, and function number 2 maybe is g of x equals 5 times x, then I can talk about them at the same time because I'm not calling them both y. One is a function f. I describe its function rule by saying f of x. One is a function g. I describe its rule by calling it g of x. Some students see the parentheses and they remember that in other contexts this means multiplication. You need to notice the context. If there's a letter outside, it's presumably the name of a function, and we're explaining what happens to the input x according to this function rule. And what I think is really a smart thing to do is to describe what this is doing using the words input and output. If you call everything x, it gets confusing, and I'll explain why later. So here we could say, oh, this function rule is saying the output will be the input value squared. X is just the name for our generic input value plus an extra 2. That's what this rule is saying. I have an input called x. What am I doing? I'm squaring that input and adding 2. Don't get caught up on the name x. The rule being described here is square the input and add 2. So for this example over here, right, let's write an equal sign. We are evaluating. That means figure out what is the numerical value. The input is 3. How does this rule work? Square the input and add 2. Square the input and add 2. That's 11. F of negative 2. Square the input. Remember that should be in parentheses. And add 2. That would be 4 plus 2, which is 6. Right? Take a moment maybe and try as many as you can right now. They get a little bit trickier, but see what you can do. Hit pause. All right, I hope you've unpaused. Square the input and add 2. We get 102. Now for the rest of these, we don't have specific numbers. We have unknowns, but we'll try to simplify them. F of t. The rule is the same. This is the same function all along. We know the rule for this function regardless of what we call the input. The rule was input squared plus 2. So this would be t squared plus 2. If the input is called t, then we have t squared plus 2. If the input is called z, we have z squared plus 2. I'm going to skip one. If the input is called x plus 9, I will notice here, the entire quantity x plus 9 is the input. That's all in the parentheses. I am applying the function f to an input that is called x plus 9. According to this rule, we will get input squared plus 2. That's what this means. Don't get so caught up on the x. The input for this example is the whole quantity x plus 9. Input squared plus 2. And if you did out the algebra here, I'm just going to do it instantly. I'm sure you could check like so. Let's contrast this with what we see up here. Here we're noticing, as far as f is concerned, the input is just x. F of x is x squared plus 2. And then we add 9, and we get x squared plus 11. So what I want you to notice immediately, we'll talk a lot more about this as we go, these are not the same. In one of them, we apply f to x, and then afterwards add the number 9. In the other one, the 9 is part of the input for f. This is very different. How do you think this last one would work? What do you think the input is? The input is the whole quantity 3x. So our rule here is input squared plus 2. And if you work that out, you get 9x squared plus 2. This is not the same as 3 times f of x. That 3 being inside versus the 3 being outside have very different meanings. So make sure you're doing practice with things like this. I might even give extras that are not from the book so that people are really solid on this. And then one last little thing, just an application. If we understand a verbal description of something, we can usually come up with our own function rule using function notation. So here's an example. A website for a concert sells each ticket for $50, and there is also a $10 service fee for each transaction, regardless of the number of tickets. If x measures the number of tickets, we want to give a formula, C of x, measuring the total cost of the transaction. So x here is sort of generically measuring the number of tickets. And we can kind of break this up as the ticket cost plus the fee. Each ticket costs $50, and we're buying x of them, so that would be 50 times x. And the fee is 10. So here we are using function notation to explain in a general way. We never even mentioned a specific number of tickets. Maybe it's 6, maybe it's 1, maybe it's 20. This is just the general rule for explaining if I know the number of tickets I want, this will tell me specifically how much money I'll be spending. Okay, that is it for this video.